We talked about proportional relationships and how to identify whether relationships were proportional. And the way we could identify that they were proportional was by finding out what the unit rate was for a given table of information or a given situation, and we created a table. If they were proportional, that meant that it had a consistent unit rate throughout, meaning we would take the y values, divide it by the x values, and it would equal the same thing no matter what. We're doing the same thing on proportional relationships with graphing. In order to be able to identify that a graph is a proportional relationship, all you have to know is that the graph has to be a straight line, meaning it does not curve whatsoever, and it's going to go through the origin, and the origin is the point 0, 0, which is your corner piece. So if we're looking at a problem like the following, we have the cost of tennis balls. If we were to purchase 3 tennis balls, it would come out to $6. If we purchase a can that has 4 in it, it would come out to $8. If the can has 5 in it, it comes out to $10. And 6 of them will come out to $12. That's what it's going to look like. So what we're going to do is we're then going to go ahead and graph each of these points. The first column on the left side is our x values. Sit down. The second is going to be our y values. So when we're graphing, x goes left and right, y goes up and down. So if we're looking at the point 3, 6, 3, 6 means that you're moving 3 units to the right, and then 6 units is moving up. So if I start at my corner, my origin, I go 3 units to the right and then 6 units up, that's where my position is going to be. Graphing points shouldn't be anything new to you. In fact, we did this at the very beginning of the year with our I Love Math graph. For the next set, 4, 8, that means, again, you're going to go 4 units to the right, 8 units up. So again, starting at the origin, you always start at the origin, go 4 units to the right, and then 8 units up, and that's where your next point is going to be. 5, 10 means we're going 5 units to the right and 10 units up. So go 5 units to the right, 10 units up. Then for 6, 12, that means 6 units to the right and 12 units up. 6 to the right, 12 units up. And then these are our points that have been graphed. Now, again, we need to check that it's a straight line and that it can pass through the origin. Right now, the way that we've graphed it, maybe it's a straight line, maybe it's not, maybe it goes through the origin, maybe it doesn't. The only way that you can check is to get a straight edge or a ruler and then see if you were to connect it, connect the dots together. Can you connect them all together with a straight line? Yes. So what I always tell you guys to do, make a checklist. There are 2 things that have to check off. We have to check off that it forms a straight line, which, as you guys already said, it does. So I put a check mark next to it. And we have to check off that it passes through the origin. And again, that means it passes through the 0, 0 or the corner. Does it pass through the origin if I extend it? Let's look a little closer. Does it? Yes. So I can go ahead and check off that that is true. Because both of these criteria are able to be checked off, this means it is a proportional relationship. It has to be a straight line. It has to go through the origin. If it's a straight line and it does not go through the origin, it's not proportional. If it goes through the origin and it's not a straight line, it's not proportional. It has to check off on both in order for proportionality to exist. Is that clear? All right. So let's go ahead and look at the next example. Then I'm going to go ahead and zoom this one out. For our next example, we're talking about a conversion of gallons to quarts. So it says 1 gallon. 1 gallon is going to equal 4 quarts. 2 gallons is 8 quarts. 3 gallons is 12 quarts. And 4 gallons is 16 quarts. So we want to know if that's graphed a proportional relationship. So once again, you're going to come over to your graph and graph the points. Then connect them to see, is it a straight line and is it through the origin? Jalen, focus. 1, 4 means I'm going to go to the right 1 and up 4. 2, 8 means I go right 2 and up 8. 3, 12 means I go right 3 and up 12. Then 4, 16, I go right 4 and up 16. So there are my 4 points. Alex, make sure you're copying. Okay. There are my 4 points. Connect them together and see if it forms a straight line through the origin. Is it a straight line? Yeah. So straight line checks off. Does it go through the origin? Yeah. It does extend through the origin. So it is proportional. I'll give you guys a moment and then switch it over to the next slide. It goes through to the corner. You can extend it down to the corner. And guys, do not try to form your straight lines freehand. You need a ruler. Okay, some of you like to try to do it without a ruler. You're going to need a ruler. Always. If you don't finish in class, it's always homework. All right, page 83. Page 83. So for here, they just give us a scenario, but they're not exactly giving you a table of information. So you're going to need to create that table of information. You need to create a table representing your X and your Y's. What does our X represent? Huh? Nope. What does your X represent? Your X-axis is right here. What does it represent? Hours. Your X-axis is the axis that goes left and right, which happens to be down here. That's the hours. Cakes is going to represent your Y-axis. Now, please do not get confused by that, because when you read the problem, they didn't put it in order of X and Y. They told you the Y and then the X. But you have to look at how your graph is labeled. Your graph will determine what your X and Y values are, even if they state them out of order. Alex? Huh? Everybody was given it. I gave it to, okay, so look around. Did someone take your paper? Come up and get another one then. Oh, okay. Okay, stop. I don't have time for that. 3 cakes in 2 hours. That's our first ordered pair. Again, 3 cakes means that the Y value is 3. 2 hours means the X value is 2. So then when I graph it, I'm going to come over here. I'm going to go to where the hours is 2, which happens to be 4 grids over. You don't count boxes. You actually look at what the labeling is. You go by the labels, not the boxes. So we're going over 2 and up to the 3. So this is where we would put our point. Then we've got the next one. 4 cakes in 3 hours. So 3 hours, 4 cakes. So I'm going to go right to the 3 and up to the 4. Then we've got 5 cakes and 4 hours. That's 4 for the hours and 5 for the cakes. I'm going to go over to 4 hours and up to 5 cakes. And now I need to go ahead and connect them. Are they connecting to make a straight line? Yes. So that checks off. The straight line checks off. Does it go through the origin? No. The origin, it does not go through it. So I put a big X by the origin, which means that this is non-proportional. If it's a straight line but does not go through the origin, that immediately makes it not proportional. If it's not a straight line, that immediately makes it not proportional. You have to meet both criteria in order for it to be proportional. It's kind of like, the Jekyll trip. When you guys got the packets for the Jekyll trip, it says you cannot have any referrals and you have to have an 80% or higher in your classes. So you have to meet both criteria to be able to go on that Jekyll trip. If you don't have an 80% in your classes, but you don't have any referrals, you don't get to go because you have to meet an 80 and you have to have no referrals. Both criteria has to be met. It's the same thing here. Both criteria, straight line and an origin, has to be met in order for it to be a proportional relationship. If one of them's not met, the whole thing is thrown off. Okay? All right, let's take a look at this one. Here, they don't give us a listing of points, but they do give us a situation. It says a person can burn 8 calories per minute. So we can still create our own table. Who can raise their hand and tell me what is the labeling for X? Bryant. Minutes. X is represented by minutes. It's right down here. What does the Y represent? Julian David. Calories burned. So how many calories we burn while running. So then we just go ahead and create our own points. If we were to run for 1 minute, how many calories could we burn? 8 calories. So I'm going to go ahead and plot. Go over 1 and go up roughly to where 8 would be. Thank you, sweetie. Oh, you have questions? Well, hold on one second. Let me finish these up. Why don't you take a seat right here and then. If I go for 2 minutes of running, how many calories would that be? 16. So that means I'm going to go over to 2 minutes and go up roughly to where 16 would be. If I run for 3 minutes, how much is that going to be? 24. So we go to the right 3 and up roughly to where 24 would be. And we'll do one more. 4 minutes, how many calories? 32. Go over to the 4 and roughly up to right around where 32 would be. So I've got those points graphed. Now we just connect and see if it goes straight and through the origin. Is it straight? No. Yes. It is straight. Is it through the origin? Yes. So it's straight. It's through the origin. So it is proportional. It is straight. It is through the origin. It is a proportional relationship. Now, on your homework, you will be identifying proportional and non-proportional based off of graphs. Now, if it is proportional, you then need to identify what the unit rate is. So let's go back to each of the problems. Yes? You connect the line, and you just extend the line until you pass through the axes. Once you pass through the axis, if it goes to the origin, which is 0, 0, then that's the origin. It has to go through 0, 0. And that makes sense. If you don't run, do you burn the calorie? No. Okay? All right. So let's go back through each problem and let's identify what the unit rate is for each of them, because that's what you're going to have to do for your assignment. So for number 1, turning back to the problems, we identified that it was proportional, so now let's find the unit rate. And to find our unit rate, all you need to do is take your y and divide it by your x. You just have to take your y and divide it by your x. Since we already know it's proportional, we only have to pick one point. So I'll pick my first point. What is 6 divided by 3? 2. So my unit rate is a 2. Simple enough. That's the unit rate. If you were to do that for every point, 8 divided by 4 is 2. 10 divided by 5, 2. 12 divided by 6, 2. Okay, if we go down to problem number 2 we also said was proportional. So again, for the unit rate, you pick your y and divide it by the x. So what is 4 divided by 1? 4. So there's our unit rate. 8 divided by 2 is also 4. 12 divided by 3, also 4. 16 divided by 4 is also 4. So when you find out that it's proportional, you need to identify what the unit rate is going to be. It says it in the directions. It says it in the directions on your assignment today. If you've identified that it's a proportional relationship, also identify the unit rate. You would need to do that. Yes. Yep. If it says explain your reasoning, because when it's graphed, it's a straight line through the origin. That's a perfect reason. It meets those 2 criteria, you're done. Okay? In fact, we used to have, probably. One of the questions that we've had on the test in the past is, how can you tell if a graph is proportional? You just have to list off those 2 reasonings. It's straight, it's through the origin. Done. All right, number 3 wasn't proportional, so does it have a unit rate? No. Makes sense, right? 3 divided by 2 is 1.5. 4 divided by 3 is 1.3 repeated. 5 divided by 4 is 1.25. So those are all different values. There's no unit rate. And then for problem number 4, it is proportional, so we need to identify again the unit rate. So you take your y and divide it by x. So if I take 8 and divide it by 1, what do I get? 8. So the unit rate here would be 8. All right. That's what you'll be doing for today's assignment. And you've got 20 minutes to be able to do this assignment. That's more than enough time to finish it in class.